Have you ever wanted to build your own advanced AI chatbot that can remember your conversations and answer questions based on your own documents? What if I told you that you could do it completely for free using one of the fastest AI models available today? In this video, I'm going to show you exactly how to build a powerful RAG, or Retrieval Augmented Generation chatbot. It's built with the latest versions of LangChain and Chainlit, powered by the incredibly fast Groq Llama 3.3 model and open-source embeddings from HuggingFace. You'll be able to feed it your own PDF documents, and it will answer your questions with context and sources, just like you're seeing right now. By the end of this tutorial, you'll have a fully functional RAG chatbot and understand every line of code that makes it work. So, let's get started. Before diving into the code, let's quickly talk about what RAG is and why we're using it. RAG stands for Retrieval Augmented Generation. It's a technique that allows large language models to access external knowledge beyond what they were trained on. Instead of relying only on their built-in data, they first retrieve relevant information from your documents, then use that context to generate much more accurate and reliable answers. This approach makes your chatbot an expert on any topic you give it. To make this possible, we're using a powerful tech stack. Groq gives us access to the Llama 3.3 model, famous for its insane speed, making the chatbot feel almost instant. HuggingFace provides our sentence transformer embeddings model. This turns text into numerical vectors so we can find relevant information. LangChain acts as our framework, tying all the components together and managing everything from document loading to memory handling. Chainlit powers our sleek, interactive chat interface built directly in Python. And finally, FAISS from Facebook AI handles the vector store, the fast database that makes all document searches lightning quick. Now that you understand the tools, let's jump into the code. You can find the full source code on my GitHub. The link is in the description. First, we import all our essential libraries from Groq, LangChain, HuggingFace, and Chainlit. Then, in the configuration section, we set the folder path for our PDFs. I've called mine fin@docs, and add the Groq API key, which you can get free from Groq's website. Here, we also define our model settings and parameters like chunk size and temperature. Next comes document processing. The function called load and process PDFs does exactly what it sounds like. It searches for all PDF files in your folder, loads them using PyPDF loader, and splits them into smaller chunks with recursive character text splitter. We do this because large language models have limited context windows, so breaking documents into smaller, meaningful sections helps them retrieve information faster and more accurately. Once our documents are chunked, we need a way to search through them efficiently. That's where the vector store comes in. In the function initializeVectorStore, we take our document chunks and use HuggingFace embeddings to convert them into numerical representations. FAISS then indexes those vectors so we can perform similarity searches in milliseconds. After that, we initialize our models. First, the HuggingFace embeddings model for text representation, and then the chat Groq model, where we pass our API key and fine-tune parameters. Next comes the fun part, connecting everything using Chainlit. The onChatStart function defines what happens when a user begins a new conversation. We send a welcome message, create a retriever to fetch relevant document chunks, and set up conversation memory with LangChain's conversation buffer memory. This memory feature is what allows the chatbot to remember previous parts of the conversation and provide context-aware responses. Then, we create a conversational retrieval chain. This combines the LLM, retriever, and memory into one single unit that handles all user interactions. We store this chain in the session so that it stays active throughout the chat. Whenever a user sends a message, the onMessage function runs. It pulls the chain from the session, shows a quick thinking, and then calls the chain with the user's message. The chain processes the query, retrieves relevant chunks from the vector store, generates a complete answer, and also returns the source documents. We format those sources neatly in the sidebar so users can see exactly where each piece of information came from. Finally, the chatbot sends the completed response back to the user in real time. And that's the entire back end. The last section of the code simply runs the app using Chainlit's command line. To start the chatbot, open your terminal, navigate to your project folder, and type chainlit run app.py-w. That's it. Your RAG chatbot with memory is now live and running in your browser. You can ask it anything related to the documents you uploaded, and it'll respond instantly with the correct context and sources. Thank you so much for watching. I hope you found this tutorial helpful. If you did, please give this video a thumbs up and subscribe for more content on AI and software development. The full code is available on my GitHub. You'll find the link in the description below. Feel free to fork it, experiment, and make it your own. I'd also love to connect with you on LinkedIn and GitHub. You'll find the links there as well. And if you have any questions or ideas for future videos, drop a comment below. I'd love to hear from you. Thanks again for watching, and I'll see you in the next one.